Let us look at now system characterization using Z transforms, isn't it? We have to characterize system based on its causality, linearity and other things. First, let us see causality given x of n, h of n and y of n, where y of n is the output of the system, h of n is a transfer function system and x of n is the input of the system. That means, I have a system, this is having a transfer function x h of n and input is x of n and output is y of n. Okay, this is what is given to us. So, we have a system which is having h of n the transfer function, then input is x of n, the output is y of n. This is what is given to us. Then what is y of n? Y of n is x of n convolved with h of n. So, I will get y of n as, when I convolve x of n and h of n. That means, when I take the Z transform, I assume that means, when I know that this is having a transfer function x of z in Z transforms and this is having a transfer function y of z, okay, and this is having a Z transform which is equal to h of z, then if I know all this, then I can write y of z is equal to x of z product of h of z. So, as you see here, the convolution resulted in a product here. So, this is what is given to us. We all know this. So, x of n is having a Z transform x of z, y of n is having a Z transform y of z, h of n is having a Z transform h of z, then the output of a system y of z is equal to x of z multiplied by h of z. And in n, what is this thing here? We see here there is a product. If you see here, this is a convolution here, whereas if I convert into a Z transfer or I convert into a Z domain, then it will be a product of these two. So, this is what is given. Okay, now we have to see what is the condition for causality. If I say this system is causal, then how does it affects your whole system functionality? Let us look into that now. So, an LTI system is said to be causal if its impulse response h of n is 0 for n is equal to 0, that is 1. So, h of n being 0 for n less than 0 means it shows that the function is a right sided function. And what about ROC? ROC is outside the outermost pole or outside the circle with radius at the outermost pole. Okay. And h of z is given by summation n is equal to minus m to plus m to h of n z to the power of minus n should be such that the order of numerator should be less than that of the denominator. So, let us just put this on the board. So, when I say this system is a causal, that means h of n is 0 when n is less than 0. What does it mean? It means that the function is a right sided function. What about the ROC? The ROC must be beyond the outermost pole. For example, let us say my pole is here. Okay. So, this will be the outermost pole and my ROC is beyond this. So, ROC will exist beyond this. So, this is about an ROC for a causal system when I am using the Z transforms. Then finally, the numerator, power of the numerator must be less than that of the denominator. So, all this will are characterization of Z transforms. Okay. Now, let us look at the next property, that is stability of a system. That is a characterization of a system is stability. Now, let me just read this. Stability: an LTI system is stable if and only if the impulse response is absolutely summable. That is, the discrete time Fourier transform h of n converges and therefore, ROC includes unit circle. A causal LTI system with transfer function is rational is stable only if the poles are all lying inside the unit circle, that is all the poles have magnitude less than 1. So, stability means we have an LTI system, when I say it is a stable, then the impulse response of h of n must be absolutely summable. That means, the discrete time Fourier transform if I take for this, then h of n converges, then the system is said to be stable. An LTI system to be stable, all the poles must lie within the unit circle. Okay. So, this is the characterization of Z transform of a stable system. Next comes invertibility, characterization of Z transform. For an inverse system with impulse response given by h to the power of inverse of n to exist, the following condition must be satisfied. That is, if h of n is convolved with h inverse of n, it will be equal to delta of n. And if I take the Z transform, the product of these two will be equal to 1, then from this I can calculate my h of inverse 1. So, let us just put this on the board. So, let us see, that means if I am convolving these two, Okay, let us say this is how we write h of n, and this will be equal to delta of n. Okay, when I take the h of z for this will be h of z, and this will be a product, and this is h of inverse of z, then this will be equal to 1. Delta of n will have a z domain. Then what is h inverse of z from this? This will be equal to 1 by h of z. Okay. So, if a system is invertible, then these are the conditions to be satisfied.